So lesson 20, we're going to talk about matplotlib for your data visualization. Before we do that, just wanted to let you know that there are many different sort of data visualization libraries in Python. And I'm just going to go through this little top 10 off some Python data visualization website. All I did was I typed in into Google Python graphics capabilities or something like that. And this is what came up. This is the first one on there. You can see matplotlib is number one. It's probably the most used, and it probably says that in here somewhere. Seaborn is another one. You see these sort of violin plots. ggplot is mirrored after R's ggplot system, so the grammar of graphics. It's supposed to do the same thing, maybe not exactly, but it's supposed to try to do the same thing that R's ggplot does, and it's tightly down here talks about tightly being married to pandas, so make sure you throw it in a data frame. You've seen us do regular old plots off matplotlib already with pandas. Bokeh, Pygal, Plotly is a way to do interactive graphics. So kind of like, R has the ability to do interactive graphics, and so does Python. Geoplot.lib is a way to do geographic sort of things and whatnot, and it looks like it's broken down by counties. Gleam, I'm not real sure. I've never used that one before, and I haven't used many of these before. So just know that they're out there. I wanted to make sure that everyone knew before we started to talk about matplotlib. Matplotlib is the most common. That's the one we'll use. It's the one that does basic graphs. And what we'll do right now in this video is I'm going to use these three pieces of data. I guess I need to bring in NumPy as well. So we're going to use these data, and we're going to graph some lines and do as much as we can as quickly as can. So it's PLT, right, because that goes with matplotlib. So PLT dot, let's see, I'm going to do dot plot, and then I'm going to graph X and np dot sign of X. And then so one of the questions that people have is, do you have to do this show? You don't have to do this show. Like I could do this, but you'll see up here where it talks about there's some object that's going to be, and then it just prints out the object. The show sort of alleviates seeing that message, and it just kind of comes up. And the show also allows you to put matter of fact, we'll do it right now. So let's just do plt dot plot x comma np dot sign. I guess I could just copy that one. And plt dot plot. So if I'm going to put two graphs, I got to tell it to do two of them. I just write it out one at a time, and then do the plt dot show. And the interesting thing is you can't hit F9, F9, F9. You got to sort of run these all together so it knows that you want them all in the same graph. And that's how you'd go about doing that. The next one is a scatter plot. So plt dot scatter. So scatter, and then what you have to do is in this X piece here, you got to put in all your X points. So I'm going to call it points, and we're going to put in all of my rows, because I think, I got it by column 1, column 2, and then let's see, the 0th one, and then points. That's why I put it in as a NumPy array. You can put it in as a regular list, but it's just harder to access the columns that way. And then I think that's all we need. So let's do, and then plt.show. Let's go F9. You see the points are in there. And then, so scatter. Oh, and then I just wanted to show you that you can do this too. You can put scatter plots in plt dot plot. Paste it. I'll just copy one of these guys, throw it down there, and then run them all together. And you can see you can put multiple. You can put bar graphs on here. Once we talk about bar graphs, you can put whatever you want to. I mean, they would look kind of funny if you put bar graphs and start at 0, but you can do that. All right, let's look at so bar graphs are a little different in that they really only have height, and then you got to be careful about where you put things, right? So what we're gonna graph this data point or this data set up here. We're gonna graph that as bars, np.arrange. So that allows me to give it a start and a stop and then a step. So I'm just going to go from 0 to, let's see, however many data points that we have. And so in this case, I got, so for each one of those groups of data, I have 4 data points. So I got to do length of data 0. So you got to pull out one. So go to the 0th row and pull that guy out. And let's go. You can see I'm just trying to get that 0th row out of there. All right, so we're going to let x be equal to that. And then I'm going to multiply it by 10 because that's going to be how wide I want this thing. So F9. And then what you do is you just do a plt.bar and then x comma data. And we're only going to graph the first one. In this first little one, we're only going to do the 5, 10, 12, and 8. So I'm just going to do data 0. Yeah, and then this plt.show. And you can see some bar graphs, right? So what it did was it went to 10, it went to the 0, right? Because that's my first. Here, let's print x. This is a capital X, that's a lowercase x up there. So x was 0, so it went there and it plotted the first number, the 5. It went to the 10. It plotted the second number, the 10. And 12 must be the third number. Let's see, data. 12 is the third number, then 8 is the fourth number. And you can see what it did. Now, what if we wanted to make those a little bit wider? Obviously, we can do that. So we just go in and we let it be width is equal to, let's just go 1 less than 10. Go width of 9, and let's see what that does. So what it does is it centers it at whatever your x value is, and then shoots out 9 or 4.5 in each direction. So 4.5 in each. So you can kind of see what's happening there. Or you could do, width equals. So we could have done something like this where we sort of set it up saying width is equal to 10, and then so I'm just going to copy this. C, Control V, and then times width, and then width's equal to width minus 1 or something like that, and we can now get it, right? So if I want width to be 20 now, F9, you can see it looks exactly the same except the x-axis is just a little bit different, right? It's going to 70 on this case and it's going to 35 there. What if I want to then do multiple bars? So that's the next problem. Let's see, I'm going to just go, let's see, total width is equal to the total width of each one of these suckers is that. The individual width is equal to total width divided by length of data 0. So think about that for a second, right? So if I had 4, because I'm going to put bars in here. Let's see, maybe data, because I'm going to put 3 bars in here, right? Because this sucker data is, I'm not going to put that number of bars in there. That's going to be how many we're going to have. I'm going to put that number of bars in there. So I got to divide by, I need to divide by 3. So I need to divide by just the length of data. All right, and that'll give us, because what's going to happen is going to put the 1 bar associated with, here, let me just bring up data. So this is what it should do. I don't know what it's going to do, but this is what it should. It should put a 5 and then put a 1 and then put a 10. So I have 3 of those pieces of data, and then it should put a 10, a 5, and a 6. So what I'm trying to do is break up that 10 into 3 equal elements. So that's what we're doing there. And then let's see, let's let x equal to, it should be about the same thing here. Let me, instead of width, it's going to be total times total width. All right, let's see what that is. 0, 10, okay, that's fine. And then for I, comma, and I don't care about this other piece. enumerate data. What we want to do is we just want to step through and go plt.bar, and then I'm going to go x plus I times individual width, right? I want to go through each one of these things and print off each row, basically, right? So I want this to start at 0, 0, 10, 20, 30, but I want to have it a smaller width because I don't want it to take up the space that's intended for this one. And this one's going to have, it's going to start at whatever my individual width is times 1, right? So just so to get an idea what's going on there. And then data I, and then all of the row or columns. So the row I and all the columns. And then finally, we want this thing to be width is equal to, I believe. And let's see what happens. And then plt dot show. All right, so let's think about this for a second. So it's 10, and if I have 3 rows, it's only going to go 3 1/3, right? So something like that. And then it's going to, the first one's going to go in, it's going to start at 0, and the second one, the second bar, so the first bar is going to have a height of 5, the second bar is going to have a height of 1, but it's going to be moved over by 3, and it's only going to have a width of 3, and then it's going to be moved over to 6, but have a width of 3. All right, so I think this will work. There we go. All right, so 0, 5. Yeah, we probably might want to put a little bit of space in there. So let's put a is equal to 1. So what is that? What should I do with that spacer? I should probably do total width minus spacer divided by that. Let's see what that does. That feels like it should work, but I don't know. All right, so we got a little spacer in there. And if you made the spacer big, you know, you're going to get a little bit skinnier, you know, skinnier graphs here, but a bigger space in between them, right? So 0.1, you can make them really, really small too. You can't even really see 0.1, so let's maybe do 0.5. So you see how this thing works. It's not terribly difficult to figure it out. I mean, you might have to play with it the first time you try to mess around with like multiple bars, but it shouldn't be. Some code in something like this should be helpful to work. All right, so that's multiple bars. Now we're going to label our graphs. So let's do plt.plot. Grab something up here. I'm going to come up here and grab this one. Let's see, I am here, Control V, and then at this point, I'm going to say plt.title. I'm just going to call this the graph, and plt.show. Again, you have to do all of these together in order for it to understand that you want that graph to be on that particular chart there. Okay, so let's label the X and Y axis. So kind of do, let me grab this information, throw that in here. Let's see, I want to do something a little different here. I'm going to increase the DPIs of this thing, just so you guys can see that we can actually do LaTeX. So you can do LaTeX here. And in order to do LaTeX, we're going to increase the DPIs, the dots per inch or something like that. So fig size. So I'm introducing a new thing here. Figure is what it's called. plt.figure, and then fig size is inside here, and that's going to be, I don't know, let's do a 3,2, and then at this point, here's where you put the DPI. We want it to be kind of large. We'll do 150 at first and see what happens there. And then plt.plot is going to be x, comma, and my y is going to be x squared divided by 20. Then I'm going to title this thing. So let me pull this up here. I'm going to get rid of this one. And I'm going to title this. We're going to throw some LaTeX in there. So you put the $signs, and then you put you got to put double slashes. I know it's just to let Python know that you really want to slash. You got to what's called escape it. And then you're just using LaTeX. If you've never done LaTeX before, or LaTeX, or whatever you want to call it there, it's just a way, it's another sort of way to write. So what this says is it's a fraction x squared over 20. That's all that says, and hopefully we get that on the side over here. And then let's see, plt dot x label. So you can see all the things that you can do in Matplotlib right there. And then maybe we label this x values and y. Values, and you could also use LaTeX in here. I just didn't in that case. And let's see. If you want, you can change the size in here too. We'll say, as a matter of fact, let's go ahead and use some LaTeX in here. So I think it should sing this in here. So let me just copy paste it, and then we'll make the size a little bit bigger so you can see how to change the size of your. Let's see what that looks like. All right. Whoa, it got big, didn't it? So let me exit out of here. All right, so the reason why we made the DPIs a little bit bigger is, so this is the title now, and this is the x-axis title. You can see if you're using LaTeX, it tries to sort of it's a typesetting deal, so it allows you to sort of typeset it and make it look like it's supposed to. All right, so that's labeling, and let's go to legend. And let me see here. Let me copy paste all this stuff. We will paste it down here underneath the legend. And in the legend, I'm with the fig size. I'll let it be the same. We'll let this be the same. But now I'm going to label. I'm going to take the title off here just for a second, because I want to put two of these plots in. So I'm going to plot x comma np dot sin of x maybe. And I'm going to label this one as this. I'm going to have it the same as this guy. So I'm labeling that one there, and we want to label this one. If you give it a label, then you can just tell it to throw the axis in, and it'll do it. So plt. I'm sorry, the legend, and something like that. So x values. Maybe we just do. I don't care about this one anymore. Labeled it, so we have a legend that says that, and then we can just let that be y, and I don't need it to be 20 anymore. All right, let's see what happens here. So you can see that it's still orange and blue, x squared over 20. You know, you got the LaTeX, and then so that's the blue one, and then you got the sin of x in there. You get the x values and y values. All right, so I don't know. I think that looks pretty good. The last thing that we want to do, and I didn't want you guys to watch me sort of play around with this thing, but if you do plt.plot, you know, help on it, you can see that there's lots of different things in here, like line styles. So in here, ls stands for line styles, and I gave it a dot and I'm sorry, a dash and a dot, so that represents the dash dot line style. And I gave it 2 dashes here, which is the dash line style. I'm changing the color from I think it was blue and orange to red and purple. What else are we doing? We gave it a marker. So if you came up here, here's all the markers that you can use, and it's not markers with an S like you would probably suspect. But if you go up here, it'll tell you that it's marker style, right? So it's just marker equals. And then, here's all of you can use a hexagon 2, a plus. I think I'm using a star and a dash here. So let's see what happens here. So think about what's the problem here. So I'm using a marker for every single one of my points. But how many points do I have, right? So let me just highlight X. Look how many points are in there for X, and that's not good. If you want markers. I mean, if you don't want markers, then that's fine. But I'm going to change that to 20. So F9, and then I'm going to rerun this thing just to have markers that kind of make sense. So here I only have 20 markers, and you can kind of see that's the star one. Maybe we give that instead of star. I don't like the star. It kind of looks funky. Let's give a plus. And we got the pluses don't look great either. Maybe you can change this marker size. I think MS is the marker size. Here, let's look. I can go back up and marker edge color. Yeah, you can change the edge marker size or MS. So we can change the marker size of the dots to MS equals 3. Let's see what that does. And I don't remember all of these little small nuggets of stuff. I used the help. I used Google in order to be able to just show you guys some of the things that Python's able to do. I don't think it's too important that you memorize every little bitty thing. It's nice to know that, I think, or to understand the big ideas on why things work. I mean, just the fact that you have to spell out purple and red. I didn't have to remember that. I knew LS was line style. I've used this enough in order to do that. I know that I can label, the plots and just throw the legend. I mean, those kind of things are nice to know because you don't want to have to remember or reinvent the wheel every single time. But just know that it's not too important for you to memorize every single little thing. All right, that is matplotlib style. Next time we will use the object-oriented style to do exactly the same thing that we just did here. All right, hope you got something out of this one, and I will see you next time.